We have seen in the previous weeks how to determine if two or more samples are similar, and also how to determine if two qualitative variables are related. Now we move further into inferential statistics to see how we can determine if a relationship exists between two quantitative variables by using correlation. Just like in the chi-square test for independence, a correlation test has two variables, one which is the independent variable and the other the dependent variable. Say for example, you're trying to see if there's a relationship between the number of absences and the final grades in a given class. Of course, the number of absences is the independent variable and the final grade is the dependent variable. You've done the study on 7 students, and here are your results. You're now ready to visualize your data on a graph called the scatter plot. The scatter plot is a simple graph where you plot the pairs of values made out by the independent and dependent variable. For example, our first point on the graph will be the pair of values for student A, your second point on the graph will be the pair of values for student B, your third point on the graph will be the pair of values for student C. There are 2 steps for constructing a scatter plot. First, you must draw and label the x and y axis. The x-axis always represents the independent variable, and so by default the y-axis always represents the dependent variable. Note that the coordinates of the axis are determined by the smallest and largest data values of each variable, but there's no absolute rule in this as long as it makes sense. So in our case, the x-axis would be the number of absences. Since the lowest value is 2, it's fair to start the axis as 0, and the highest value is 15, so we'll put it at 15. The y-axis would be the final grades. The lowest value is 43, so we could start it at 40, or at 30 if we so please. And the highest value in our results is 90, but why not end the axis as 100? As I said, there's no absolute and fast rule in this, as long as it makes sense. Now for step 2. Plot each point on the graph. As I said before, one pair of values is 1 point, so you would have as many points as you have objects. The first point has the coordinates 6 and 82, so it's graphed like this: 6 on the x-axis and 82 on the y-axis. Then we go on to plot all of the points: 286, 1543, 974, 1258, 590, and 878. And that's it. A scatter plot. Once the scatter plot is drawn, we can start examining it to check for different patterns and describe what we are seeing. Now, what is the shape of the plot? Is it linear, like this, or non-linear? Note that the methods for non-linear relationships are way outside the scope of this class. Now, what is the direction of the plot? Is it direct, positive slope, or indirect, negative slope, or even neutral? What is the strength of the relationship? Is it strong with almost no scatter, weak with a scatter with a pattern, or absolutely no pattern at all? And finally, are there any outliers to the plot, like this guy over here? Let's get back to our number of classes missed versus final grade scatter plot and try to describe it using the 4 concepts. It's very helpful if you draw an imaginary straight line that passes as close as possible to every single point, like this. Now we can see that the plot is linear, there's no major curves here. It is indirect because it is dipping downwards as we go towards the right side of the graphic, meaning that the more classes are missed, the lower the grade. Although there is a small amount of scatter, one might say the relationship is rather strong. And finally, there doesn't seem to be any outliers. Now let's see what else we can get from this set of values. The strength of the relationship is quantified using a correlation coefficient. Although there are a lot of different coefficients to choose from, we will use the Pearson Product Moment Correlation Coefficient, or PPMCC, or if you prefer, the Pearson Correlation Coefficient. This guy, symbolized using the letter R when dealing with samples, and with the Greek letter rho when dealing with population values. The value our correlation coefficient can range from -1 to 1, with of course 0 straight down the middle. A correlation coefficient of -1 indicates a strong negative linear relationship, whereas a correlation coefficient of 1 indicates a strong positive linear relationship. In this aspect, 0 indicates, of course, no linear relationship. Let's take a look at what these different values look like on a scatter plot. In this first plot, we notice all the points align perfectly and that the line is going upwards. As such, this implies a strong positive relationship, which would give us an R of 1. On the second graph, it's exactly the opposite, with an almost perfect line going downwards. We have a strong negative relationship, which would give us a coefficient of -1. Now the next plot is what happens when our R is of 0. Notice how there's no pattern here, just what appears to be a random flecking of points. And finally, these last two give us something more in the middle, with R values of 0.5 and -0.5.